Historically, the use of faceted geometry in downstream applications, such as structural analysis or manufacturing, has meant that a level of reverse engineering needed to be performed to generate the topology that was acceptable to these downstream applications. With NX12 and convergent modeling, the design engineer now has a set of tools inside the reverse engineering application that enables him to very quickly generate this topology that is accepted by both manufacturing and analysis. The following demonstration will outline some of these tools and techniques. So here we have our convergent body, which is considered to have just one single face. For some of our downstream processes, we need to create further topology to support these. Historically, this would have meant performing some reverse engineering to create surfaces to support these downstream activities. Now, with convergent modeling technology and in NX12, we have the ability to divide the single face of the facet body into multiple faces so that we can better support FEA and manufacturing. So how do we go about selecting the areas that we want to divide? Well, we could use some of the new paint selection techniques in NX12, but that could be potentially time consuming. So how about we use one of the commands that's been around for a while called detect primitives. This command automatically recognizes and color codes typical topology shapes such as planes, spheres, cylinders, cones. We can then use these color regions to assist us when selecting the areas that we want to divide. So we activate the delete facet face command and set our selection criteria to color region. Notice how easy it is now for me to select the areas that I want to divide. I just pick within the colored region. Once I've completed my selection, I can then apply the divide facet face command. And now we can see, if we set our selection criteria to face, that I now have individual faces to be selected for downstream activities, such as FEA or CAM. As mentioned earlier, you can use some of the other selection criteria to divide the facet body up. In this particular case, we're just using a paintbrush. And I select the area that I want to divide. Once I'm happy with the area, I apply the command. And there you can see we have that individual convergent face in the middle of the part. If you ever make a mistake, or if you ever want to get back to one facet body with a single face, then you can use the merge facet faces command to achieve that. You select the facet body, you apply it, and it removes all of the divided areas. So just to recap, we can now support the integrated workflow between design and manufacturing and design and analysis when working with facet bodies. Convergent modeling in NX12 enable the design engineer to create the topology necessary to support these downstream activities without the need for any time-consuming reverse engineering.